So welcome everybody to our STEM series number 2. This is our iFly Physics of Skydiving session. So thank you all for joining us. A few housekeeping announcements as we get started. One, if you haven't already done so, if you can please change your Zoom name. What I mean by that is on the bottom left of your picture should have your name. If you hover over it with your mouse and then you right click it, you should be given the option to rename. And so if you can put your name and your school and your grade, that will be very helpful to help identify, who's on the line, and also for me to monitor our attendees. So here with us, we have Miss Casey. She is an educator from iFly Indoor Skydiving. So we hope to have a great session today. Other just general notes about it is we encourage participation as much as able. So when she asks, if it's a question and you have capability, please unmute yourself and ask a question when appropriate, or go ahead and type your question in the chat box. We'll be monitoring the chat box. As questions arise, again, we please ask you to be participatory. At the end of the session, I will go ahead and put up a link so that you can get your attendance counted for today's session. I will go ahead and place the link in the chat, and I'll give instructions for that later on in the session. But for now, I will go ahead and pass it over. Thank you for joining us today.
Thank you so much, Anita. Hello, everyone. Welcome, welcome. I'm so glad you're here. Happy Tuesday. So I'm excited to be here with iFly. I have a question, a couple questions for you guys. If you were to throw a ball into the air, why does it fall back down? Anybody have any ideas of that?
Gravity.
Gravity, that's right, absolutely. So knowing that gravity is pulling the ball back down, how do you think you could keep the ball up in the air longer?
Increased air density, more surface area.
Increased density, more surface area, excellent. So what could you do to keep the ball in the air forever? Somebody said hit it again. Okay, I'm gonna read these real quick. Throw it with more force. Okay, what could you do to keep the ball in the air forever? Less weight. Okay, what else?
Changing the gas that's inside.
Say that one more time.
Changing the gas that's inside.
Changing the gas that's inside, okay. Take away the gravity, reduce the gravity.
Have air push up. Just have air push up on it.
Have more air push up on it. I like this.
Put helium inside the ball.
Put helium inside the ball. Okay. Have a constant force below it. Oh, we've got some, hold it. Oh, that was good. That was good. Hold it. That was funny. I love it. Love the sense of humor. That was fun. Well, if I can get my slides to work. Having some technical difficulty, bear with me. There we go. Goodness. Well, here at iFly, we make science, technology, engineering, and math fun with STEM, and that's what I'm here to do for us today. So basically what's going to happen is I'm going to do an interactive presentation. You guys are doing an amazing job of chatting with me in the chat box. Somebody said give small wings so that it slides through the air. We're also going to be doing some physics demonstrations through some videos. I'm going to walk you through a lab activity, but I want you to continue to interact with me. I don't want to sit here for 90 minutes and talk. That to me is not very much fun. So I love the interaction with this. Somebody wrote, if the container, you can increase the density of the air heavier than the ball would float up. I am loving this. I can tell this is going to be a great STEM class. Please keep them coming. I love this. So without further ado, let's continue forward. So a little bit about myself. My name is Casey. I just so happen to be from Kansas City, Missouri. I'm over here in the Midwest. I have been with iFly. It'll be 2 years in January. Virtual has just come to us, and I'm embracing that and excited about that. I'm also a substitute teacher. So I'm doing in-person substitute teaching as well as virtual substitute teaching and a hybrid of both. So this kind of fits right into that mold. And I tell you what, iFly is my passion, and I just feel very, very blessed to be here with you guys. You can see some of the classes that I've had, some of the experiences people have had. You can have maybe infer some things that they were doing in these fun pictures, but I tell you, it is super, super fun to be here, and I'm glad to be with you guys today. Thanks for coming. So what exactly is STEM? Well, STEM, like I said, is science, it's technology, it's engineering, and it's math. My question would be, is what types of jobs or careers would you see in each of those acronyms? So like science, what kind of jobs would you see for science?
Biology jobs.
Biology jobs, okay. Geologist, chemist, okay. What else? Doctor, science teacher, good. Engineers, math, I love this. What about technology? What careers could you see for technology?
Software developer.
Ooh, software developer, very good.
Robot builder.
We're going to get to the engineers in a minute. You guys are good. Computer artists, programmers, good, good. On engineers, I've gotten a lot of electrical. I've gotten mechanical engineer. What other kind of engineering? How about domestic engineer? You know, like at Miss Anita and I, we're domestic engineers. We've got other things than just what we do. Programmers, yes. Civil engineer, excellent. I'm liking this. So what about math? What jobs can we do in math?
Astrophysics.
Astrophysics, excellent. Math teacher, excellent. Theoretical physics, lots of math. Mathematician, yes. Statistics, excellent. A banker, very good. I'm liking this. Economist, yes. Crime scene, and I am loving this. That's right, a carpenter. I don't know anything in life that does not require STEM, some part of STEM. Any type of scientist, absolutely. A welder, very good. Well, let me tell you, there's exciting futures that await for you guys in STEM. I'm hoping that having this class is going to help you maybe have a future in STEM. Chef and a baker, absolutely. Don't you have to measure and do the math on those things? Construction worker, I love this. Treasurer in the courthouse, absolutely. I love this. You guys are spot on. I love this. Well, STEM is used in the real world to solve problems and improve lives, but I'm kind of curious if you guys have any ideas of what specifically STEM could be solving right now. Who has an idea? I'm gonna get a drink of water.
Coronavirus.
Absolutely. Cancer, that's excellent. What parts of STEM is helping, would help with coronavirus or would help with cancer?
The science part.
The science part. Global warming. Artificial body parts, okay. What other things could STEM use that you could use STEM in real world to solve the problems? I'm loving these answers. COVID is the #1 in my book. Math for vaccines, absolutely. World hunger, excellent. I love the way your brains are thinking, absolutely. A tumor, some 3D printing to practice on an exact replica of a tumor. Oh my gosh. Any kind of disease or virus, you guys are so spot on. How to prevent car accidents, absolutely. Diseases. And there is one thing that engineers all do that's the same. Does anybody know what that is?
Use technology.
Use technology. I like that. It's a 2-word answer.
Make something for the better of the public.
Make something for the better of the okay. So that was like a wonderful sentence. Can you squash it into 2 words that all engineers are? You're okay. Again. Olivia is spot on it. She said, find a problem and fix it. So those are called problem solvers. And guess what? Every single one of you are future engineers because you're engineering right now. You figured out how to get on the computer. I struggle with technology, so I might have some flubbies and stuff. But every single one of us are problem solvers. We all work together. Excellent. Excellent. I love this. So you all are my future engineers, and that's why I'm so excited you're here today. And this should take you into future careers of STEM, and that makes my heart super excited. You never know, you might become a STEM educator, you might become a flight instructor, you might become an aerospace engineer. The sky, pun intended, is the limit. Now, what makes STEM so much fun? Oh, where do I begin? Where do I begin? I tell you, to have the opportunity to be able to feel like you've jumped out of a perfectly good airplane and float like that in a secure, safe place, to me, that's fun. Learning about science, technology, engineering, and math, to me, that's fun. I geek out over that stuff. So we're gonna make STEM fun for you. Now, I have a question for you. If I'm blowing on a dandelion, there is a force that's happening. Just as that last slide I showed you where the instructor was near the student flying, there's a specific force that's happening. Can anyone tell me what that force is?
Air Force.
Air force. So the air is the force. I see lots of wind, lots of push, lots of wind force. I like it. I like it. So a force is either a push, like we're talking about the wind pushing the student underneath in the last slide, or it can also be a pull. So in this case, the wind is pushing the air onto the dandelion and pushing the seeds out. Has anyone ever done that before?
Yes.
Or should I say, has anyone not ever done that before? Because if you're a kid, I'd like to think that you did some dandelion blowing in your day. Some of us still do, right? I mean, come on. Some of us still like to do that. So one thing I'm going to show you is I have my fan going over here. You still do? Good answer, Olivia. You and I are on the same team. I'm telling you what. I have a piece of paper and I have my fan going. What is going to happen if I put my piece of paper up? Is it going to stand still? Is it going to fall? What's going to happen?
It's going to fall.
Paper is going to bend.
The paper's going to bend because why?
Of the force from the air.
Force of the air, right? So here we go. I got my piece of paper. I'm going to hold my hand behind it at first, okay? So it's going to be the fan is going to be the wind blowing like on the dandelion. Let's see what happens to my paper. You ready? It's going to fall over. Very good. You guys are super smart. You guys are super smart. Now, what would happen if I had my piece of paper and I dropped it? If I let it go, not that I dropped it, but what if I let it go out of my hand? What would happen?
It would fall.
It would fall. Why would it fall?
Due to the
Because
force.
Gravity.
it's too light.
Gravity would pull it.
The gravity's going to pull it down, right? It will fly in the direction of the air or wind that's pushing it. I like it. It will slide back and forth. Yes, gravity's pulling it down. Well, let's see what happens here. The air will pull the paper. Will the air pull the paper down? I got to pause on that one. Let me think about this. Is the air pulling my paper down?
No.
No, it's pushing it down.
No, it's
What's pulling my paper down? What's that called?
Gravity.
That's right. I was going to say, somebody just put on there, gravity's going to pull it down. So here we go. You ready? Yep, there it goes. It just disappeared. The wind pushed it with its force, and the gravity pulled it down. You guys are good. I tell you what, I love this. So gravity pulls an object down. The air can push the object. That's what you guys were talking about, right? Some of you were saying the air can push it, the gravity's pulling it down, right? They will punch to the air direction. I'm just reading some of the notes. Come on, slide. There we go. Well, I am going to show you what one of our tunnels looks like at iFly, just so you can get a visual. I realize that you guys are not close to one, but that's okay. I'm going to bring it into your home right now onto your computer screen. So with iFly, we use the entire building to be able to do our indoor skydiving. So we're going to talk about exactly what every nook and cranny of the building does, because every single ounce of it is used when doing our indoor skydiving, when we do our STEM classes, when they practice things of that sort. First of all, has anyone been to an iFly indoor skydiving before?
No.
Oh, I have one person has. Madison has.
no.
That's okay. Oh, okay. Malin has. Good. I'm just curious. There's no right or wrong answer. I just like to, know. It's a pretty neat opportunity. And like I said, I'm going to bring it to you in your home so you don't have to stress about it. iFly is like a university. Oh, that's fun. Excellent. All right. I'm loving this. Well, hopefully one day you guys will have the opportunity to come to an iFly indoor skydiving facility, because they are incredible. All right, after you enter the facility, well, let me go back real quick. Do you see this right here? This is what's considered the iFly wind tunnel. This is where you're going to be flying when you're inside the tunnel. Air is going to, and we're going to talk more in depth about this. This is just kind of a brief overview. Air is going to be circulating around the whole building of the wind tunnel. And we're going to talk about that. And you're going to be right here in the middle. Okay. So when you enter the doors of iFly, it's pretty awesome sauce. This is what the inside of the tunnel looks like from the outside. So you get to have a real clear view of the people that are inside. So there'd be a flight instructor and there would be a student. Now, when you look up look straight up of the wind tunnel, this is what you're going to see. And the reason they're doing this is to make it, I'm trying to think how to say this. They're trying to make the airflow smooth, safe, and fun. Does that sound fun?
Yes.
We want to have fun. We want to be safe, and we want to be able to see our fellow students. You know what I mean? So when you're there with a group or you're there with your family, it's entertaining. And so we want you to be able to see what's going on. Does that make sense? Like if you jump out of a perfectly good airplane, bye-bye, you'll see the person as a little ant coming down, but you won't have the same opportunity. Okay, Tristan says, timeout, Casey, it looks a little scary. I understand why you'd feel that way. When you look up, that would be like, timeout, this is not okay with me. Some of you are afraid of heights. I don't love that you're afraid of heights, but I embrace that you're afraid of heights, because when you have the opportunity to fly at iFly, the instructor's right there with you. You're at waist level, so you never go any higher unless you do a high in the sky, which we'll talk about later. But I promise you, it is very safe and it is very fun. you'll do it like a real airplane. Oh, so you just want to skip the iFly and go straight to the airplane. That's okay. Good for you. Good for you. I love that. So we're going to keep going. You guys are having fun here. So here we go. This at iFly is a closed loop vertical wind tunnel. When iFly very first started, they didn't have a roof over it. So all the air just went straight out the top. Now, being engineers like you guys are, what do you think would happen when all that air, oops, I didn't mean to do that. When all that air was to leave the tunnel, what would happen?
There would be no air circulation.
There'd be no air circulation. What else? You might fall. Okay.
You might hit the ceiling.
No, okay. So there isn't a ceiling now, is there? Would you feel safe if you didn't have a ceiling?
No.
I wouldn't feel safe. I mean, that's just me. Some of you are like, I'm going through an airplane, so it really doesn't matter. No ceiling or ceiling. I'm good with that, right? But those of us like me are like, I need a little more security, a little more structure to make me feel safe. It'd probably be fun until you hit the ground. I agree, Bryson. You're right. It probably would be fun to hit the ground. Well, here's what the engineers did.
And if you didn't have the air circulating, then you wouldn't get clean air as you were flying up. All you would have is dirty, turbulent air coming from a single fan. But now that you have it circulating, it's going through and it's getting rid of all the pathogens that are in the air.
I love that. I love that. And they took it. So here, I'm going to give you an example. I'm not going to give you an example. I'm going to talk to you about how this works. So there is up here, there's an airfoil shaped turning vane in each corner to maximize the efficiency. So there's one here at the bottom and at the top. Okay, there's 4 of them. So far, so good. Then how many fans are there?
There's 4.
Do you see that? Most people, and I forgot to ask you this, so please forgive me. I forgot to ask you where you think the fans are. Before I'd shown you this, where would have you thought the fans would have been?
On the floor.
That's what I would have thought too.
Yeah,
when I first started at iFly, I'm like, would only make sense for the wind to push me up because that would make the most sense, right? Well, the engineers realized that they want clean. I don't know who just said all that amazing information, but they want clean, less turbulence. They want a safer, smoother opportunity for you guys to feel like you've jumped out of a perfectly good airplane without actually having done that. It was Ricardo. Thank you so much, Ricardo. I like to call people by name. So forgive me if I don't call you by name. I'm going to do my best. So what they decided was, what they figured out is if they put the 4 fans up top of the tunnel, they're going to draw air through the flight chamber and then drive it through the air towers. So here we go. So we've got 2 over here and 2 over here. So they're going like this and they're going down the sides. And then they're coming down here to the water cooled assemblies providing consistent air conditioning. Because let me ask you this. If you have a whole bunch of wind going at you really, really hard, is that going to be a cold or a hot air temperature?
A cold
It'd be
air.
very warm.
Let's think about this. So here's your first little experiment. Let's take your hands and let's rub them together really, 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 really hard. How are your hands feeling?
Hot.
They're hot because what's happening?
The friction
Friction.
between the
The
atoms.
friction. There you go. That's right. So iFly is like, we want you to have a lot of speed for the wind to be able to get you to push up, but we don't want you to be uncomfortable. So we're going to cool that down in the air conditioning, and then it's going to go through the inlet contractor, which is a narrow upside down funnel, if you will. And then that's going to circulate the air back up there and cool off. And so that way it's a comfortable experience for you, depending on what region you're in or what time of year it is. The loop make because there do not have space to go away tight. I don't understand that. I'm sorry, Leo.
Is that why all the indoor skydiving buildings are a square?
Absolutely. Great. Great question. Yes, they're a square so they can go through those specific areas of the return vents and of the water cooling systems. Engineers are constantly improving these tunnels. So if you guys ever get a tunnel, it'll be new and improved from the tunnel that I'm at. Does that make sense?
Yes, it does.
Excellent. I was going to say something else. Let me cover all my tracks here. I'm trying to see. Anybody have any questions?
No, ma'am.
You guys are good. I'm loving this. You guys are good. All right, we're going to keep on going. The loop. Okay, here we go. All right, so let me see. These two look like they jumped out of a perfectly good airplane. What do you guys think? Is that what it looks like to you?
Yes.
Now, who has the desire to do that? I'm really curious. I will do it. Leo says, I'm going to do it. Jasmine's like, I'm doing it. Look at you guys. You guys are not scared. Bryson's like, nah, I'm with you.
I've seen
You'd
people
like to try it. Huh?
I've seen people break their noses while skydiving.
Break their nose?
Yes.
Okay, you've got me curious on that one. How are they going to break their nose?
Some have fallen like a belly flop on the floor and hit their head and then squashed their nose.
So when they landed with the parachute, they went face first?
Yes. They didn't open the parachute at the right timing.
Okay. So Elena says, you know what, broken nose is worth flying out of the sky. More power to you, Elena. I'm not mad at you. Well, the wind tunnel is going to give you the opportunity to feel like you have just jumped out of a perfectly great airplane without, number one, breaking your nose. Number two, without being that many thousands of feet above ground. And number three, without the parachute to be safe. So, having said that, I have a question. How long does it take for you to jump out of that perfectly good airplane, okay, before you go splat on the ground?
20 minutes.
I'm sorry, what?
Maybe
20 minutes.
20 minutes, okay. Is that my buddy Ricardo?
Yes.
Uh-huh, I'm getting familiar with your voice. Okay, like 60-30 what? 5 minutes, 20 minutes?
Maybe
4
like
minutes?
1 or 2 minutes.
You think what?
Like 1 or 2 minutes.
1 or 2 minutes? Okay, somebody said about 9 seconds. Boy, that would be fast. It depends on if you're afraid to jump. Hilarious. Very funny. Yeah, getting out of the airplane is going to be the first thing. I get it.
Well, that also depends on how you're falling. If you're nose diving, you're going to fall faster than if you're sprawled out.
Ooh, is that Ricardo again?
Oh.
I love it. We're going to talk about that in just a second. You guys are good. It depends on definitely how your body is. It depends on how far the airplane has gone up into the air. The actual time, are you ready for this? 30 to 45 seconds. Drop. I know you said 30 seconds. You didn't. Don't laugh at me. I know. I'm telling you. 30 to 45 seconds. That is fast, in my opinion. When you're in the wind tunnel, you get a full 60 seconds to be able to do it, to experience it. A lot of skydivers come into the wind tunnel to practice for that very reason, because it's one of those where you can't just go chink and be done. Yes, even with the, no, not even with the parachute, till you have to pull the parachute. Sorry, I wanted to clarify that. I almost said that too fast. Wrong. I'm like, no, time out. That's right. Now at iFly, there are kids, I know you guys are in 6th through high school, give or take, middle school to high school. there are kids at iFly between the ages of like 8 and 10 that practice in the wind tunnels and actually compete. And you don't have to be 8 to 10, you can be older, you could be an adult like me. There's no age, there's no male or female, there's none of that. If that's something you're interested in, we would certainly be more than willing to talk to you about that. How fast is the wind going? That's a really good question, Madeline. And that just depends on where you are in the sky, literally speaking. Does it matter about your weight? Ooh, good question. Mass does make a difference. Absolutely. It sure does. Okay, what do we mean? Mass makes a difference. Okay, just making sure I'm not missing anybody on these questions. So yes, what else is going to make a difference is when you're flying, okay, so you've jumped out of the airplane and you're coming down, what's pulling you down? We talked about the two forces. What's pulling you down?
Gravity.
Gravity.
Always, right? Do you know what is pushing you up?
Air resistance.
Air resistance or drag force, right? Does that make sense?
Yes.
So at some point, your gravity is going to meet your drag force. Does anybody know what that's called? Aerodynamics. Aerodynamics is what makes you smooth and makes the air go around you. Oh, crud, I just lost my screen. I don't know what I just did. I made you guys great big. There we go. Sorry about that. I'm hoping you didn't see what I just did, but that's okay. Terminal velocity. Excellent, Grayson. And if I pronounce your name wrong, please forgive me. I am really going to do my best here. That's right. So when the gravity and the drag force meet, that's called terminal velocity. That's what we do when we get you inside the wind tunnel. I've got the two pictures. This arrow is about the exact same size as this arrow. That is demonstrating that you have reached your terminal velocity. At that point, you are not speeding down as fast, you are just hovering or floating. And that's what we accomplish at iFly to get you guys to do that as well. All right. We're going to talk about, come on. So the gravity is pulling you down. The air is pushing you up, and I said that that was called drag force. Yes, and then in the middle is the terminal velocity. I got myself flustered there. So, what forces are acting upon the skydiver? The force of air pushing you up, aka drag force, and the force of gravity pulling you down. Can't see my little spots here. Now, do you notice how my arrows are in different sizes right now?
Yes.
Okay. Why do you think my drag force is so small? Because I just jumped out of the airplane. Exactly. Spot on. You just jumped out. So the larger arrow is what pulling me down?
Gravity.
Gravity. That's right. Different amount of force. Gravity. Good deal. Oh, did I go too fast? Go back. That's right. The force of gravity is now pulling you down. So whereas the last slide where they were equal, the arrows were the same size, we were at terminal velocity. Now the gravity, because we just jumped out of the airplane, is really pulling us down fast. That's the 30 to 45 second mark before we hit that terminal velocity and are balanced. Does that make sense?
Yes.
All right. All right. What forces are acting upon this skydiver? We just touched on this. The force of air pushing you up, what did I call this?
Drag force.
Drag force. Somebody's asking if there was more force from the air, they would be going up. Air resistance, drag force. That's right. Good job. So now I've got my arrow going up, about a medium-sized arrow. Now the force of gravity pulling you down, now those are equal. Do you guys see how they're about the same size?
Yes.
Does that make sense?
Yes.
So the forces acting upon the skydiver when the parachute comes out, let's think about that for a second. We have more area for the wind to catch.
Teacher.
Would you agree?
What's her name? Casey.
So therefore, the arrow going up is showing that you have a larger area to catch that wind. So your drag force is now has a larger opportunity to collect more air. Your gravity pulling you down, what's going to happen to that?
You're gonna go up and then you're gonna start falling.
Okay, Bryson's got it. You're going to be coming down slower now. Would you agree with that? When you don't have the parachute and you just have the human body coming down, are you coming down fast or slow?
Faster
Fast.
without the parachute.
Right? And now that you've got the parachute and you've got more area catching the wind, that's going to slow you down. There we go. You're going to be like the paper. You're going to fly away. I love it. I love it. So the forces acting on the skydiver are drag force pushing you up and gravity pulling you down. So here you go. Here's a question for you. Do all objects need the same amount of wind to fly?
No. Some
No.
need.
No, surface area.
Say that again.
No, it depends on surface area.
Depends on the surface area, okay? Would depend on how big the parachute is, okay? Well,
it also depends on the density of the object.
depends on the density and the mass of the object, okay? What else?
Depends on the size of the object.
Okay, size can definitely matter. You're on the right track. You're on the right track.
Weight.
Okay, mass would make a difference. I like that. Okay, so in this picture, I'm a little perplexed, okay? I have a flight instructor standing with both feet down, but yet I have a student who's able to fly above him. How would that be possible?
The student weighs less, so they fly up.
Okay, the student can weigh less. I agree with that. He weighs more. Okay, what else? What else do you see?
She's smaller, so there's less air resistance.
Less air resistance. What about how her, aha, there we go. Angelina, is that how you pronounce that? Spot on. The positions that they're in, you guys were all around it. The positions they're in. Just like when the parachute was out and that was a larger collection from the drag force, there's more area for her to be caught with the wind to push her up. Does that make sense?
Yes.
Versus the person standing, he doesn't have as much area for the wind to push him up into the air. Man, you guys are good. Just making sure. Okay. All right. I got to keep it on the time here. I apologize. I'm getting excited. Okay. So very quickly, I've got two flight instructors. One is head down. One is on his belly. Which one is going to take more wind or drag force to put in the air?
The one
One
that
on his
has.
belly.
Say it again.
The one on his stomach. Wait. Repeat the question
Which
again?
one's going to take more wind to keep up into the air?
The one that has his
Oh,
head
the one
down.
on his stomach.
Head down.
The one who has his
Head
head down
down.
because he's got less frontal area. The guy that's laying on his tummy, there's more frontal area for him to be caught by the wind. Does that make sense?
Yes.
Excellent. Kind of like with the parachute. Awesome. So engineers and scientists use mathematics to quantify physical principles because we want to be able to predict what's going to happen. So I'm going to be showing some videos on different objects flying in the wind tunnel. So the first one I have is a sphere. And it's going to be competing against, or I don't know how you want to say it, it's going to be flying against, I'm moving my chat so I can see things, against the block. Okay, you ready to see the difference? Let's see if I can play them at the same time so we can see them in unison. So what do you guys think are going to happen with the cube and the sphere?
The sphere weighs less.
The sphere may weigh less, but what about the shape of it? Do you think the shape makes any difference at all?
Cube has
Yes.
more surface area.
There's less surface area on the sphere, and the air is going around the sphere than on the cube. It's just staying on one side of the cube.
Do you see how they're bouncing off of the walls differently? They're going in different directions. Exactly. You guys are getting it. The sphere has a smoother side, so the wind is able to catch it differently. I love this. You guys are good. All right. Let me pause these so I can get to the next slide. There we go. Now I'm going to show you a googly ball. The googly ball is plastic. How do you think it's going to fly in the tunnel compared to the wiffle ball? I couldn't hear you. All right, I'm going to go ahead and play the videos here. What do you notice about the googly ball?
It's going up higher. And
Going
falling
up
down
higher.
again.
Wiffle ball has
Once
holes,
it's-
yes.
Once it's toppled over, it just falls.
Do you guys notice that the googly ball is changing shapes at all?
Yes, they're becoming a little bit flatter.
Can you guys see that? And it's also spinning. What about the wiffle ball? Is the wiffle ball just kind of lingering in the air, or is it spinning also?
It's also
It's
spinning.
spinning.
And what's making it spin?
The
Air resistance.
The air in the holes is making it spin?
maybe that's why aliens have their spaceships round.
Maybe. Oops, no, pause. There we go. Okay, now, here's a prediction I would love to know about. So I'm going to have a wiffle ball and a Nerf rocket ball, okay? They're definitely different masses, but I want to know which one, they're the same size but different mass, which one is going to fly first?
The wiffle ball?
Okay, here we go. I'll let you guys watch this. I got Nerf, I got wiffle ball, I got both sides of it. All right, let's see what happens. So same size, just a different mass. They're having to increase the wind. They're slowly increasing the wind. The wiffle ball's starting to move a little bit. The Nerf ball's not doing anything. So why do you think the wiffle ball was able to move and not the Nerf when they were the exact same size but different mass?
It looks like the Nerf rocket's stuck in the grate.
I promise it's not. I realize it does look like it. I don't know if you could see on the camera or the TV screen right there. It shows the velocity or the miles per hour that it has to go. Aha! It has holes. It's less weight.
And the Nerf rocket is facing down.
The Nerf rocket is facing down. Okay.
It's lighter than the Nerf rocket.
Okay. And it's also a lesser mass. Aerodynamic. I like it. Very good. That's right. Excellent. You guys are good. Oops. Stop. There we go. There we go. Okay. Now, I have a red ball and I have a blue ball. This is going to be another example of frontal mass, okay? You can see that the red ball is physically larger than the blue ball. So which one do you think of these is going to go in the air first? Not faster, first. Blah, 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 blah.
Maybe the blue ball.
Blue ball? Okay, I'm getting blue and red. I'm getting both.
Red.
Okay, here we go. I'm gonna play the video. Push the button. Don't stop sharing. There we go. Whoa! This has to do with the frontal area. Do you remember the picture I showed you where the flight instructor was standing there and the student had a larger frontal area and they were able to fly above the flight instructor? It's the same thing here. The red ball, wherever it went, it's hiding there somewhere. The red ball has a larger frontal area. And so therefore it takes less wind to raise it up into the air. Red because I can't. Okay. All right. Oops, come on. There we go. Now, talking about frontal area. Do you think the flight instructor, it's going to take more wind to make him float when he's standing up or on his belly? Which does he need more drag force, more air? If he's standing, we're talking about frontal area. So a larger frontal area requires less wind, a smaller frontal area requires more wind. Here we go. Watch this. So here he is. The wind is getting stronger. Watch him when he goes to belly, what happens?
He goes up faster.
He goes up. Now he's standing just like that. And now he's on his tummy and he can float. Now, one thing I want you to watch is watch his hands, watch his arms, watch his legs. Every move he makes allows him to do different things in the tunnel. So this is going to be fun. I'm going to have a small, heavy object, a ball, versus a person. What do you think is going to fly first?
Maybe the person.
Do you think the person's going to fly first or the ball, and why?
The ball.
I see a lot of person. I see a
The person
ball.
has more surface area. The person's going to fly first.
Has more frontal area. Okay, let's find out. You guys are good. It is the person. They have more frontal area. So therefore the wind can catch it and they can make it go up, make him go up into the air, make her or him. It could be a her too. You guys are good. I can't get anything past you guys. Aha, my favorite. What happens to water when it gets in the wind? Anybody have any ideas?
It goes down.
Okay.
It becomes super turbulent.
Do you think it's going to be a puddle? Do you think it's going to be raindrops? Do you think it's going to be a stream? No idea. I love it. It dries up. That's a good one. I haven't had that one before. All right, well, let's find out, shall we? This is really cool. It's my favorite. Whoa, super slow-mo. Just like us, water has frontal area and it can split and go into smaller droplets. It can combine and get into bigger droplets. Is that cool or what? That's like my coolest video ever. All right, so those are up in the air. Some of them are coming down because some of them are larger. Some of them are going up because they're the wind is taking them up. What's going to happen when this flight instructor walks in the middle of that? What's going to happen to his flight suit? What would happen to his pitcher?
He would get wet.
He's going to get wet, or she's going to get wet. They're going to get wet. You're right. And why is that, though?
Because we are dry and water is wet.
Okay, right. But what's happening to that water to make it come back down on his head? He's interfering
Gravity.
He's interfering with the drag force. So when he's in between the air pushing up the water and the water that's above him, it's just going to come and hit him in the head and hit him on the flight suit and catch it in the pitcher. Does that make sense?
Yes.
Good deal. I love this video. And like when you go through a car wash and you turn the air on, when you go through the dryer part, what happens to all the water on your windshield?
It starts falling down.
It starts going zzz and blowing away, right? Blows off, dries up. Absolutely. Gosh, you guys are good. Poof, vanishing. All right. Now, this is one of our flight instructors, and they are going to show you some basic and some advanced moves that they do while they're in the wind tunnel. This person's very experienced. It's not his first time in here. So here we go. Watch this. And again, watch every finger, hand, arm, every head movement, foot movement, leg movement, and watch how he goes up and down. When he changes positions, he's changing his frontal area, and that's making him do different moves and making him go up and down, fast and slow. Here we go. So you can hear the wind is getting stronger. Whoa. And do you see how he's just barely moving his body, moving his extremities? He's spread out, he gets up higher. He clenches himself together, he gets down lower. He is adjusting his frontal area to make himself go up and down. Now you can hear it increasing, and he's staying where he is. But watch his body, watch what he does. He spreads out, he goes straight up. He gets a smaller frontal area, and he comes straight down. Just from barely moving his body. He's like Superman, exactly, or Spider-Man. Absolutely. All right, that was cool. He did a great job. So we're going to do a paper airplane lab activity. As engineers, when we do something, the first thing we do is we ask what needs to be solved, would you say? Then you imagine what you would like to create. Then you plan it, you create it, you improve it, and then you start all over again. That's what the engineers did with iFly, and that's what we're going to do here today as well. And there are perfect. Miss Anita has activities for the teachers and students that want to complete this later, and she's going to post the event on the website for you guys. Just things to think about. Think about the lift of the airplane when you're making it. Think about how heavy it is or light it is. Think about the thrust of going forward, the drag force of keeping it back. Think of all those things when you're doing your airplane. Your goal is you want it to be fast moving, you want less pressure, slow moving, depending on your wings here. Just got lost for 3 seconds. Oh, I did it again. There we go. Anyway, just be thinking about those things when you guys are doing your activity. All right. Does anybody have any questions for me?
When are we having the other class, the next class?
That I don't know. That is a great question. For those who have to leave at 4:30, please complete this link. It's required to get credit. And Miss Anita Gonzalez has left that link for you guys. What questions can I answer for you guys? You guys were good. You had a lot of conversation. I love this. For those who don't have to leave right now, I know a lot of you have practices and things of that sort, so I'm wanting them to have an opportunity to know that you will get further instructions after the event is over. There'll be a survey. Don't just put your name on it. You'll need to complete the link completely. But I want to make sure that if people have questions, I answer them.
Have you personally been in the iFly?
I have done indoor skydiving multiple times, and so is my daughter. Where's the nearest iFly facility? I'm not for sure where you are, James. I can tell you that there are iFly buildings all over the United States. There's some in other countries. We have them on cruise ships. You can go to iFlyWorld.com to see a location near you. If you're going on vacation with a family member or some friends or something, you can always just go to iFlyWorld.com, see if there's an iFly World near you, make a reservation. We would love for you to come out. Obviously, I would love for you to come to Missouri or Kansas, but I understand being on the West Coast.
There's one near me. It's just like 1.5 hours away.
That's not bad at all. That would be a great day trip. That would be so much fun. And then make sure you post it on Facebook so you can show your experience and everything.
So, well, if there's no any additional iFly questions, we will go ahead and proceed with the rest of our event. I do want to just give some, well, first of all, thank you, Miss Casey. I want to say that. Thank you for having.
You're welcome.
I hope you guys learned a whole lot, I should say. And as for some of you that were interested in going, down there, possibly I will talk. We did the session apart from a flight just because there isn't a tunnel by us, but maybe I could reach out and see if there was any kind of coupon thing for any of our participants, and I'll definitely pass that along. So some of the logistical things to get credit for attending today, you do need to complete a survey. So So the survey link I did put in the chat a couple of times, and I will place it again. You guys have within the next, well, I guess up until tomorrow morning to complete it. So ideally, just if you click that, it'll pop open another window. It literally takes about 2 minutes to complete. It gives us your name, your school, has you answer a couple questions about the session, and that's how we're going to track attendance. So teachers and students, please complete that link for us. There was a question about the next STEM Series event. So our next STEM Series event is scheduled for 2 weeks from now, October the 20th, same time. You would just, and then you would go to, as of today, that registration link is going to be gone from today's event. And then the next, as of tomorrow, tomorrow or hopefully by Thursday, it'll pop up on the next one. And so our next session is going to be on fire ecology and forestry. So they're going to be testing combustibles and, discussion about the recent forest fires. So should be a really good session. So thank you guys all for participating. In the chat, it was, so tomorrow we have another meeting. No, you might have another school meeting. I don't know that with your teacher, but as far as the STEM series goes, this is something with statewide MESA that you do register for, and they're about every couple of weeks on Tuesdays at 3:30. So the same site that you registered with, nmmesa.org, if you go on there, typically for our STEM series in the bottom left, there'll be the picture of the next one that's coming up. So that's really easy to find if you just click that. Or if you want to navigate through our resources, it'll go down and you can click on digital learning. So that is where, to go ahead and go register for the next ones. But thank you guys all for coming. Again, I cannot stress this enough. Please complete the Survey Monkey link. If you are having problems with it, if you don't know how to do it, please ask. Once I stop the recording, I'll go ahead and stay on the line. So if anyone needs technical help, but if you click on this, it should pop open another button in your internet browser really easily. But for now, thank you, Ms. Casey, and you guys are all dismissed.
And thank you guys so much for participating. I